So finally, at long last, we are going to start circuits. You guys have been asking us for a while about this for a while, so here it is. And we're going to start off with something called Ohm's Law. You may or may not have heard this before. And then we're going to look at kind of the simplest type of circuits, and those are series circuits. So let's go ahead and get going. All right, so some basics of circuits and how we think about them and how we draw them. So when we draw a circuit in physics, we have some power source. This is called an EMF source for electromotive force, although it's not a force. And what exists here is the difference of energy. So this would be a positive terminal. This would be a negative terminal. Say I have a battery. So this symbol right here stands for a power source. Okay, and that could be an outlet. It could be a battery. If it's a battery, actually, probably wrong with these. But the idea is that the longer lines, we say it's at a positive voltage, and then the negative line is actually at 0 volts. So say for this one, that side's at 0 volts. And if this was a 9-volt battery, the positive side would be at 9 volts. Now, we haven't really talked about voltage, but I think it's important to understand a little bit about it in order to understand how a circuit works. So a voltage is a measure of the potential energy of a charge. So the higher the voltage at a position, the more potential energy a positive charge would have at the position. For historical reasons, we define electric potential energy in terms of the potential energy of a positive charge. A negative charge actually, would have kind of opposite potential energy. But let's not worry about that for right now. So when we have a battery and we say the positive is at 9 volts, we mean that a positive charge at that location of the battery has 9 joules per coulomb of charge of potential energy. And so what we do is, it's kind of stuck right here unless we provide a path for it to decrease in potential energy. It's kind of like a ball falling down towards the ground. It decreases the gravitational potential energy as a charge goes from a high voltage around to a low voltage side. It decreases in electric potential energy, and that's the drive. That's the driving thing. This decrease in energy. That's what drives the charge through the circuit, and then the battery essentially pumps it back up. Okay, the battery acts as a pump, and it pumps the charge back up, and then it goes all over again. So this is our battery. This is where it all starts, and then we have our wire. So we have a wire with a line, and then in this course, all we're going to look at as far as part of a circuit is a resistor. So for a resistor, we draw a kind of a zigzag right here. Okay, so this zigzag is a resistor. And so a resistor it's a circuit element, so it's something we put in circuits, and sometimes it literally is just a resistor. So it's this it's something that we put in a circuit in order to decrease the current, to slow things down, to provide some, in a sense, electrical friction in that circuit. It could also be a light. It could be a motor. It's something that require the charge has to expend some energy to get through it. And so this is this line for a resistor. And for the circuits of this course, these are the only things we're going to look at is this power source here, which can be various voltages, and then resistors. And this one only has one resistor. We could put more than one resistor in it. But we're just looking at like power source and resistors and different ways we can arrange things and how we calculate the voltage at different parts of the current. So how much potential energy charge would have at different parts of the circuit. I know I said current, but different parts of the circuit. The current through the circuit. Okay, so current, I guess I'm kind of assuming you guys know what current is. Current, just to define current, a current is a flow of charge. So it's going to have units of coulombs per second, and we give that a unit of an ampere. Okay, so whenever you hear amps, okay, we symbolize with an A. When we hear of amps, that's the current flowing through the circuit. All right, so that's the very basics of circuits, and obviously you can put cool things like capacitors, inductors. It's all kinds of cool stuff you can put in here. But we're just going to start out in the baby steps, and so we'll have our power source, and then we have our resistors. Okay, now if that's all you have in your circuit, then you can use something called Ohm's Law. And what Ohm's Law does is it relates the voltage in a circuit to the current. And you know what, guys? I'm not sure why we use I for current, but that's the variable we use. Okay, so this is the current in amps times the resistance. Now resistance, so that's the resistor we're talking about. This is measured in ohms. Okay, and we give it the Greek letter omega. Okay, and this is our voltage. And this is Ohm's law. Okay, what this says is that the current in a circuit, okay, depends on the voltage and the resistance. So the more voltage you have, the higher the current's going to be. The more resistance you have, the lower the current's going to be. Yeah, and that's pretty much it. It just relates to these three things. And, you know, you can have, you know, kind of the super triangle of power. You know, and I don't know. I always debate about whether I should do this or not. But, you know, we have V, I, R, right? So you can use Ohm's law. Say you want to calculate the voltage. Say you know the current going through your circuit and the resistance of your circuit, and you want to calculate voltage. So what you do is you kind of hide the V, and then it's just I times R, right? If you want to calculate the resistance, okay, you kind of hide the R, so you put your finger over the R, and that's going to be V over I. So I know it's just a shortcut for the algebra. I thought it was fun on you guys. I don't know. I want to tell you guys about it. You can do this with F equals MA, or, you know, anything where like something's equal to like two other things. You make the triangle of power here. So anyway, V is equal to I times R. Okay, and that's Ohm's law. And so we'll work problems using Ohm's law, and you know, for the next 2 days, and various ways we can do it. But the first circuit, I want to kind of start to apply this to circuits because I think Ohm's law makes more sense, you know, in the context of a circuit. The first type of circuit, the simplest type of circuit that we're going to talk about, is a series circuit. So in a series circuit, we have the resistors, and they're all lined up back to back to back. In other words, there's only one path through this. All the current has to go through each resistor. Okay, there's no other pathway. Can't get around these resistors at all. Now, interesting fact, the current in physics, this is called the conventional current. The conventional current direction goes from positive to negative. So in a sense, we pretend, even though we know this doesn't really happen, we pretend that the charge that's flowing is the positive charge. Like I said, in physics, everything's based on positive charge flow. So we would say the current goes from the positive, and that's at 18 volts. It goes through all these resistors, and after it goes through each resistor, it's going to lose some of that energy it had, some of this 18 joules per coulomb, or 18 volts it had initially. And so by the end of it, after it gets through the whole circuit, it's going to be at 0 volts. Okay, on this side, it gets pumped back up to 18 volts and starts all over again. Okay, so this is a series circuit. And, you know, so I want to present this in class, and I'm going to show you how we use Ohm's law to analyze this. But what we can do is we can use Ohm's law. We can figure out things like what the current, you know, in the circuit is, you know, what the total current in the circuit is, what the total resistance is. Okay, and we're going to use Ohm's law to do that, and I'll show you guys how we do that. So I hope this was helpful, and I hope you guys took good notes too. If you guys have any questions, please let me know.